really stack some books up. That's about as high as I'm going to be able to get it, which is not as high as the tripod normally was. So the angle's going to be a little off. Okay. I need to clean you at some point. Alright. Number 4. Okay, so you said you want me to go over part A again?
Yeah.
Okay. So anytime they're asking for anything, linear approximation doesn't matter. Locally, it just means that it's right around there, because as we talked about with linear approximations, they only work for areas close to that line, or close to that point, sorry. Once you start going further away from that point, the linear approximation is going to not be as good. So that's why we say it's a local linear approximation, because we only use it right around there. So basically, just want you to write the linear part.
Yeah.
So we obviously know what the x and the y are. So the 2 and the 6, they give us that. The question is, what is your slope when you're writing this? Well, we know a little bit more calculus than what they have at this point, so we should hopefully understand that P of t is the amount of people in there. So if I need the slope, the derivative, that is the rate of people coming into the park. Not like just into the park, but the rate of people either entering or leaving the park total. So if we look at the functions they gave us, A of t is the people coming in, and L of t is the people leaving. So the rate of people, because it's a weird just way of saying it, like the rate of people for the park would be the rate of people entering minus the rate of people leaving. And that would be the total rate for the people of the park. So that's why our P prime will be A of t minus L of t.
What's the number of people, though?
If you look, though, the first thing it says to do is write an equation for the local linear approximation and then use it to do that. So the first thing is we have to write the line.
Oh.
Okay, so the first thing we have to do is, like I said, just write our equation for the linear approximation. So it'll be y minus 6, because they gave us that. And then we can do p prime of 2, and then x minus 2. The hard part is finding this p prime of 2. But we have to remember that p prime of 2 will be equal to a of 2 minus L of 2. Whatever that is, because it's a very weird equation with sines and cosines and stuff. Okay, does that make sense? Yes, no, maybe?
Wait, what?
Does that make sense?
Yeah.
Okay. Also, Mac, because I know you aren't work, you haven't been here. You don't have to submit the FRQs, buddy. As long as you have them as one person's done it, we can go over them. So we're just gonna grade them. You're gonna grade them by hand when we go over them. Okay, so for part 1, give yourself a point if you got the slope correct. So p prime of 2 should have been 0.401484. Give yourself a second point if you got the equation of the tangent line, which is what I have on the board, but with that 0.401 input in place of the slope, the p prime of 2.
At first I had 600, but now I have 6. So
That is, both of those answers technically are correct. You should have 620, hopefully. Oh, you mean for that part? I got you. No, okay, yeah, definitely put 6 in there. 600, I see. Because the actual answer ends up being 620 people.
yeah.
So your actual answer you should have gotten should have been 6.201.
Yeah.
But when you have to remember that people is counted in hundreds, so you could have said 620 people. They would have accepted that, but you really should just have. Um, I guess it wouldn't have mattered. They're looking for probably just the answer there, so 6.201. But I would definitely you should always include units as we've talked about. So since P is measured in hundreds of people, you should have said 6.201 hundred people, or hundreds of people would have been fine. Okay. For part B, P double prime of 5, using correct units, interpret the meaning of P double prime. So what would P double prime represent?
Isn't it the rate of people
Rate of
at
change,
the
rate of
venue?
change.
So yes, you gotta be careful by just saying the rate of the rate, though. As Tanner used a little bit better term, rate of change. So what you should have for P double prime, the interpretation would be it's the rate of change of people at the. It's weird, but the rate of change of people is changing at a rate of blah. It's kind of a weird thing, and they have asked this question multiple times. So your answer you should have gotten should have been negative 0.679.
I see. I couldn't get the answer.
And then what that means is that, and this is where you have to be careful, you do have to mention at t equals 5. If you don't mention at t equals 5 when you're giving your justification, you're probably not going to get the point on this justification. So you should say at t equals 5, the rate of change of the number of people is changing at a rate of blah. And it's like I said, it's a weird, I hate when they have this interpret these rates of a rate. It's so stupid. But it's just the rate of change of the rate of change of people. So dumb.
What was the correct answer?
Negative 0.679. So you should have did a prime of 5 minus L prime of 5. Because P double prime is a prime.
Yeah, that's what I tried, but I guess I put something in wrong.
Check and make sure you're in radians, most likely.
Okay.
Because you do physics too, so that's the most common culprit for you. Does anybody need me to show that part out? I don't think so. That's probably pretty easy.
No, it's just the math.
And this is calculator, so you should not have done that by hand. Did you do it by hand, Rudek?
No. So I might have just typed it in the calculator wrong.
Okay, so yeah, that's what I would check, is just make sure you have those. Make sure you put them in like the correct order. Make sure you had AFT and LFT in the right places and stuff like that.
Oh, did Cambridge ever say anything yesterday?
Yeah, we'll talk about it at the end.
Okay.
Part C, rate of change of people changes from negative to positive. So you're just looking at AFT minus L of T. Does it ever equal 0 anywhere? Yes.
It says specifically from negative to positive.
Yeah.
Wait, you're looking at LT?
No, you're looking at P prime.
Okay.
Because the rate of change of P of the number of people, that is P
Yeah,
prime.
that's
So you're looking at A of T minus L of T function, and you're asking yourself, is it ever go from negative to positive?
So you set it equal to 0.
You basically set it equal to 0 to your number line analysis. And then basically it's kind of a weird MVT, IVT thing that's kind of going on. But I don't really know what basically you're looking for is the derivative negative, and then does it turn to positive? So it's zeros, you should have gotten 5.811 and 6.548. And then, I mean, you have a graphing calculator, you can just look at the graph. So this is an easy question as long as you know what you're looking at. So the rate of change of people in the park is A of T minus L of T. So you just need to look at that graph. Also, something I don't know if you guys know, you can do that, pull up the graphing calculator real fast for you. So switch over to the graphing calculator. So I can just leave these in there. I don't know where they came from. But if you have these two in your graphing calculator, if you go down to y3, you can put like y1 minus y2.
Yeah.
And then if you don't want to see the other graphs, if you go to the equals and hit enter on it, it'll unhighlight the equal sign. And when I go to look at the graph, it won't be on. Oh, I had to change my window probably. Zoom 6. So it'll only display that graph that you want to see as long as you have the other two unhighlighted. That way you don't have all three graphs on your window at the same time. But you can still graph the two functions. And that lets you still use y1 and y2 separately, like for different parts of things and stuff like that as well. You could also just do then the derivative of y3 if you needed the derivative of the whole thing. So there's all kinds of different things you can do, but that's a pretty little nice trick that you can use there if you didn't know about that. Okay. So part C should have been yes. If I didn't, I don't know if I get the answer or not. Apparently it's negative in between 5.811 and 6.548, but then it's positive after 6.548. So yes, the answer is yes. Okay, part D. A rectangular transsectional line size increases in hardness.
What is the correct answer on this one?
I'm still trying to finish reading. That's the section increasing. Okay, so the answer should have been 12 square feet per hour.
I got that.
So we're looking at the area, right? What is the rate of change of the area? So if it's a rectangle, so area equals x times y. And then take your derivative and plug in 1610 and the dx dt and dy dt. Do I need to do that one?
Easy.
Okay, I'll take that as a no. Alright, moving on to B. That one video, progress. Alright, part B. No piecewise derivative, okay. So find w prime of 7 using correct units, explain it in context. Okay. This is a non-calculator, so this is all done by hand. So your w prime of t should have been 1/4 t minus 4. Should have been easy because you're using the bottom one. And your answer should have been 3/4.
Yeah.
So you get 2 points for that, one for finding the w prime and one for getting 3/4. And then the in context of meeting at, again, this is very important. Don't forget this part. We talked about it a lot last year. At time t equals 7, you have to mention when. So at t equals 7, the depth of the water is changing at a rate of 3/4. I would put increasing, personally. I would say the water is increasing at a rate of 3/4. They always say it's changing at a rate of. That way you kind of don't have to say if it's increasing or decreasing. It's a bypass. I think that's a cop-out. The rate of the water is increasing at a rate of 3/4 foot per hour is what I would say. And if I would have got a negative, I would have said it's decreasing at a rate of 3/4. But that's just to avoid ambiguity and to kind of skate around a way to do it without having to say that. Anybody need me to do any part of that one? Okay. Part B, the graph of W is concave up. Use the tangent line to the graph of W to show. Okay. So tangent line should hopefully have been pretty easy. We're doing it 2.5, so we are going to be using the top equation in this case for the parameter or for the piecewise. So you need W of 2. So you should have got 32 over 5. You need w prime of 2, which you should have got to be negative pi over 10.
I got negative 1/5.
So what's your w prime?
Negative 2/5 sine of pi times t over 4. And all that times 4 times t over 16, or t over 4.
What?
No?
Oh, it should have been over pi over 4, sweetie. So the
Which one?
negative 2/5 sine pi of t over 4. That's good. And then
Okay.
times the derivative in the inside, which is pi over 4.
Gotcha.
And then when you simplify that, you can get negative pi over 10, because you just put those together, sine pi t over 4.
So your final answer is negative pi over 10?
Sine of pi 4. And then for when you plug in w prime at 2, yes. Because when you plug in the 2, you get sine of pi, and sine of pi is 1. No. You get sine of pi halves. Sorry. They were already plugging in. Sine of pi halves, which is 1. So you get negative pi over 10. So you just had your coefficient wrong out front. Everything else, I think it sounds like you did right.
Mm-hmm.
Okay. And then you write your tangent line. And your final answer, Jesus, this is a terrible answer, should be 32/5 minus pi over 20. Do I need to do part of that for anybody?
No, that's greater than 6.
And that is greater than 6, which is basically you're supposed to say pi. I guess like it's weird because that's not relevant. That's not just like evident that that is less than or more than 6. But I guess they're just supposed to just let it say that that's more than 6, I guess. I don't know. Because you're just showing it, you're not proving anything. That's really weird, though. But yeah, 32 over 5 minus pi over 20 is more than 6. Especially without a calculator, that's a really weird question. Okay. Part C. This is a L'Hopital's rule question, apparently. Yep. So if you try to plug them in, you should get 0 over 0. Remember, in order to get credit for using L'Hopital's rule, you do have to show limit of the top and the limit of the bottom, both being equal to 0 separately. If you did not write that out, you do not get points. And then once you do L'Hopital's rule, you should get an answer overall of negative pi over 10 minus 4. Do you need me to show any part of that out? Okay, I'm going to take that as a no.
Easy.
Okay, hopefully it should have been pretty easy. Again, just make sure you write out the two limits separately to use L'Hopital's rule. Otherwise, you cannot do that. Okay, moving on to number 2. So basically, you're just taking the derivative of that, and they give you the answer. So, does anybody need help with A? I mean, it's just a quotient rule. You just gotta simplify it, which is a pain in the ass because it's multiplying
Yeah,
out
I
stuff.
had problems on the math.
Okay, that's
You
fine.
know,
I'm definitely
like
gonna need someone
I
to read me that function so I can. Cause I'm not gonna be able to memorize that.
okay. You ready?
Yep.
E to the 2 minus t,
Uh huh.
all of that minus 2t
Okay.
divided by, all of that divided by,
Mhm.
e to the 2 minus t plus 3t.
So e to the 2 minus t minus 2t on top, and e to the 2 minus t plus 3t on the bottom.
Yeah.
Okay, so
Did
obviously
you
it's...
shave your head?
I was waiting for somebody to ask, yes.
Wow.
Whoa.
Let me see the front. Twitch is gonna lag.
It'll show in a second.
Yeah.
Yeah, it will. Okay, so just quotient rule. So low,
Oh my
D high.
Can't see the front. Oh, there we go.
Yeah,
Oh
it takes
my
a second.
gosh. That's crazy. Wow.
So you got low, derivative of the high is going to be negative e to the 2 minus t minus 2 minus high, and then d low would be negative e to the 2 minus t plus 3 all over e to the 2 minus t plus 3t squared. So that should be your derivative. At that point, you should do your distributions, combine like terms, and nothing on the bottom cancels. So you just gotta check and make sure your distribution matches what they have for their top.
Yeah, I need help with that because I
Okay.
just couldn't get like 5. I don't know.
That's fine.
Like the coefficient.
So when I multiply these two, you can add them. Hold on, what does their answer look like so I know which direction I'm going? So it's just going to boil out to some e to the 2 minus t's. Okay, so I don't want to mess with that because they will end up canceling, it looks like. Yeah. Okay. So when I multiply these two, it's just negative e to the 2 minus t squared minus 2e to the 2 minus t minus 3t e to the 2 minus t. When I go to distribute the right-hand side, the first one's negative, but I have a subtraction, so it becomes plus e to the 2 minus t squared, which will cancel out with that first one. And then minus 3e to the 2 minus t minus 2t e to the 2 minus t minus...
Is it
plus...
3t? Right?
No, because you did the derivative of 3t. The second part's the derivative of the bottom.
Oh, junk, the second part, never mind.
Yeah. And then all of that over the bottom, which is e2 minus t. So the squared parts that I have cancel. You get a negative 2e to the 2 minus t and a negative 3, so that's negative 5 e to the 2 minus t, and then 3 and a 2, so again minus 5t e to the 2 minus t plus 6t, hopefully, which is what they got. Unless I did something wrong. Oh, the t should have canceled. Did I miss something on the first part? Oh, I did. Wow, I didn't even do that last distribution. So, never mind. I forgot to add in here. I didn't do the last ones. Just moved ahead. Minus 6t, so they cancel as well. All over. I'm not going to rewrite that.
I guess I have my signs wrong somewhere, because, let me see. Yeah, I do.
You just have to really be careful with that negative in the middle. To be honest, that's probably where you made your mistake. Because it can be tricky to do the distribution, including that extra negative.
So what happened to the 6t?
If you look at the first one, you'll get a negative 6t by multiplying the last two. And if you look at the second one, you get a negative 60, which is a positive
Yeah.
60, so they cancel.
Gotcha.
I just forgot the negative 60 on the first part when I wrote it out for some reason. Wasn't paying attention.
Okay.
All right. Part B.
Yeah, I didn't get this one.
Okay.
Yeah, me neither.
At t equals 2, particle q is at rest, and time t equals 2, particle p is moving towards particle q, is particle moving towards or away. So just look at the velocity of, well, okay, so you gotta look at two things. You gotta look at locations of particle p and particle q, which they give you functions for that, and then the velocity of particle p. So did you find where particle q is located?
At 2?
Nope.
Yes, at 2.
It's at 1, I
That is
think.
correct. And then did you find where particle p is?
At 2? No.
Okay, so you need to have, in order to know if something's moving away from, think about this. If you're, obviously, let's just say both, like, Anna's going out to have a bike ride again, but she's going to go over to your house, Abby. If I know she's moving at a velocity of 5 meters per second, is she getting closer to you or further away from you?
Closer?
How do you know that?
You said she's moving towards my house?
I didn't say that. I said she's going to go towards your house, but I said she's moving at 5. Do you know which direction she's moving?
Oh, no.
So do you know, also, do you know if she's going towards your house first or going to the store first? Maybe she's going to buy you a drink. Maybe she wants to go to
Okay, well,
Starbucks.
I got P of
Aw,
2 now.
nice.
So that's what you always want to think is where are they located. So I guess I don't need a number line. So it should have been negative like 3/7, I think. So P is over here and Q is over here because P was negative and Q is positive. Their locations. So now, after we have their locations, because I know Q's at rest, all I have to ask myself is which way is P traveling?
Wait, so Q of 2 is 1 and P of 2 is what?
You should get negative 3/7 when you plug it in.
Okay, that's what I got.
And then you look at the velocity of P. What you end up should getting the velocity of P at 2 is negative 15 over 49, so negative, because that's the only part that really matters. So which way is P going?
It's going in the negative direction.
And negative would be which way?
Left.
Left, so it's easy to set left and right. So I think it probably says, yeah, it's moving along the x-axis. You have to be careful. If it would have said y-axis, then it would have been up and down. So since they told us x-axis, we can use left and right perfectly fine. So it's moving left. So is that moving away from Q or towards Q?
Away.
Away. Yep.
Okay.
So anytime you want to know if something's moving towards or away from it, you got to know both their positions and which direction they're traveling. Okay, so easy explanation there is particle P is to the left of Q, and moving left, Q is staying stationary, therefore P is moving away from Q. Something along those lines. Okay, part C. That should be pretty easy for you guys. Oh, nice. And again, it's the polynomial one, thankfully. I was like, please don't tell me they have to take the derivative of that ugly quotient already. So it should have been pretty easy. Your value should have been 6.
Yeah.
Okay, cool.
Yeah, you guys wouldn't have any trouble with that. And then part D. Apparently, this ends up being another L'Hopital's rule question.
I got that.
Yeah, I knew to do L'Hopital's rule, but
No, I mean, I just looked at the answer.
oh.
Describe the position of particle P and the position of particle Q as T approaches infinity. So let's just do the limits of both of them. So do the easy one first. Always do the easy one first. Do Q. The limit as T approaches infinity of x of Q of T is infinity.
I got that.
Like
Wow.
that's super easy. Everybody should have got that. However, the x of P is a little bit harder. When you try to plug in infinity, you do get you should get negative 2/3.
Okay, I got 2/3, but that's fine. Negative 2/3.
Yeah, because the 2 on top is negative. I
Cool.
don't like the idea of them requiring you to apply L'Hopital's rule because it doesn't say it. And you guys are all smart enough, especially with as much series and stuff as we've done, that you should
Yeah.
be able to definitely do that without doing L'Hopital's
I
rule.
didn't do the L'Hopital.
You should,
or-
like honestly, if they should be able to, you should be able to get credit for that without L'Hopital's rule. And on the actual AP test, I would assume you would. Like you do not have to use L'Hopital's rule. You can, but then you have to show out all this extra work. I would just, if you just wrote limit of t goes to infinity of that and wrote negative 2/3, I would argue that you should get full credit for that. Now, if it said specifically use L'Hopital's rule, then you'd have to, but it does not. So limit equals negative 2/3 done.
Okay.
Does everybody see why it's negative 2/3?
Mm-hmm.
Yeah.
Okay.
Um,
All right, real quick.